Hello and welcome. My name is Alexandra Pavlik, and today, on behalf of the Wageningen Food and Bio-based Research Team, I have the pleasure to present to you a project concept on sustainable and healthy frying, which is entitled Microstructure-Driven Design Rules for Sustainable, Healthy, Safe, and Tasty Fried Products. The reason why we think this project is important is the fact that deep fat fried products are very much loved by the consumers due to their taste and texture. But we also know that health, safety, and sustainability of such products presents a challenge to food industry and academia. On top of it, the Netherlands alone produces roughly 4,000 tons of spent oil on a yearly basis only from potato processing operations. When we looked into the vast scientific research conducted so far, we observed that various optimization strategies have been tested throughout the entire frying process. Such strategies involve usage of vacuum, ultrasound, microwave, PEF, superheated steam, and application of different coatings on a variety of products such as potato fries, vegetables, and various buttered products. This shows us that the focus was mainly on improvement of deep fat frying, which was measured through the reduction of oil uptake. Few researchers focused on sustainability calculations, and overall, arbitrary choice of processing and product quality methods make it really difficult to objectively compare the impact of technical solutions that were applied. We conclude from the state of the art that the relationship between the quality of fried products and the physicochemical factors combined with processing is not fully understood. We believe that by understanding of the product microstructure, we can compose a set of design rules which will link processing and formulation steps with product quality, for example, physical properties such as porosity or hardness, and ultimately sensory and consumer acceptance. At WFBR, we have been developing tools to probe microstructure of French fries. Examples on this slide include XRT, which is X-ray tomography, confocal laser scanning microscopy, and transmittance microscopy. Within this project, we really aim to generate cross-disciplinary and multi-scale understanding of the interplay between the physicochemical factors, processing steps, product microstructure, and its quality. We propose two routes. First one is aimed at the optimization of the industrial deep fat frying based on current technologies using our systematic, objective, and hypothesis-based approach. The second route aims at disruptive innovation, where oil-free processing is developed. Both routes will deliver better control of processes and product quality, positive impact on health, reduced contaminants formation, and improved sustainability. At WFBR, we have been working on development of scientific hypotheses based on soft matter approach, combined with processing expertise and analytical method development. We focus here on industrial frying, par frying of French fries. In this approach, we have separated the core and the crust of the fry because they show significantly different microstructure. We have decided to design processing requirements specific to cooking of the core and drying of the crust. Par frying in oil results in dry crust layer where potato cells are separated, creating porous structure, which is partially filled with oil. On the right, you see an example of French fry microstructure, which is visualized with XRT, where clearly the crust layer could be differentiated from the structure of the core. Par frying in oil, mechanistically speaking, is a drying process with high heat and mass transfer rates. Such high heat transfer rates are needed to prevent potato cells collapse and thereby ensuring high quality crust. This collapse of the potato cells is related to glass transition temperature of potato. The graph on the right shows how glass transition temperature changes with moisture content of the material during frying. We hypothesize that processing material below glass transition temperature can improve structure. Below, you'll see the XRT image of a French fry processed below glass transition temperature without oil. Next to it, we developed methods to quantify the distribution of pores throughout the structure of the fry. This is a relatively quick method that allows us to monitor the impact of processing on the microstructure of the fry compared to a benchmark, a reference. On top of the experimental work, we have been modeling the heat transfer rates during par frying in oil, both in the core and in the crust of the fry. The aim was to match those heat transfer rates with alternative heating technologies where no oil was used. The graphs on the right show computed temperature profiles of a reference process, which is par frying in oil, together with 4 alternative methods, A to D. We can conclude from this that method D, which is a combination of heating techniques, provides promising and similar heat transfer to the crust when compared to par frying in oil. Techniques A and D are not using any oil. Attempts to remove majority of oil from the par frying step aim to improve health, reduce the formation of some of the contaminants, but also to improve the sustainability of the whole production chain. To test the environmental impact of oil removal, we have been using WFBR developed agri-food chain greenhouse emission calculator. With this calculator, we gain insights into the hotspots in the whole production chain and also information on how different intervention scenarios will impact sustainability. We have structured this project into 4 interlinked work packages. I would like to stress out here that this is a concept structure, which we hope to further shape with you. In work package 1, we want to develop scientific hypotheses aimed at specific parts of the production chain that is of importance to you, our partners. Those hypotheses will be tested in work package 2 and 3, with the feedback loop to work package 1 allowing for the creation of design rules for frying processes or steps in the production chain. Experimental work package 2 is focused on optimization of the current processes in terms of quality, safety, and sustainability. Work package 3 is focused on ambitious oil-free processing, where alternative frying technology is developed. And work package 4 will run throughout the project trajectory, and initially it will focus on scoping and establishing boundaries of the scientific approach, and later it will focus on evaluation of, for example, sustainability impact and health effects. Finally, as the PPP project is co-created with partners, we would love to hear from you on what are the key aspects of this project that would make it relevant for your company. To help with answering those questions, we have composed an inventory form with few leading questions, which would massively help us when writing up the project proposal and preparing our face-to-face meeting. We look forward to hearing from you. Thank you very much for your attention.